OpenAI just released O3. This is AGI. And before you flame me in the comments, let me explain why I'm saying this, OpenAI is saying this, and the ARC prize is basically showing it. When you see the results, you will be stunned. It is far better than anything else out there right now.
So for the last day of this event, we thought it would be fun to go from one frontier model to our next frontier model. Today, we're going to talk about that next frontier model, which you would think logically maybe should be called O2. But out of respect to our friends at Telefonica, and in the grand tradition of OpenAI being really, truly bad at names, it's going to be called O3.
All right, so there it is. Their next frontier model. This is beyond O1. And yes, they had to skip O2 because there is a telecom company that is named O2, and they didn't want to obviously have copyright issues. This is a brand new next generation frontier model beyond O1. Kind of insane to think about because it feels like we just got O1. And when he says reasoning, he's talking about test time compute, being able to give these models plenty of time to think through a problem and then come up with a solution. This is the next generation of model. This is the next generation of AI technology. Let's keep watching.
Actually, we're not going to we're going to announce two models today, O3 and O3 Mini. O3 is a very, very smart model. O3 Mini is an incredibly smart model, but still, really good at performance and cost. So to get the bad news out of the way first, we're not going to publicly launch these today. The good news is we're going to make them available for public safety testing starting today. You can apply.
So like he said, we're not going to get the actual models. We're not going to be able to play around with them yet. And as soon as we can, I'm going to do a full test of it, but we get to see the benchmarks, and they did benchmark it against the ARC prize, and the results are stunning. Not only the ARC prize, but of course they benchmarked it on math, coding, reasoning, everything. And it is leaps and bounds better than anything else that we've seen.
We'll talk more at the end about when these models, when we expect to make these models generally available. But we're so excited to show you what they can do, to talk about their performance. We've got a little surprise. We'll show you some demos. And without further ado, I'll hand it over to Mark to talk about it.
Cool. Thank you so much, Sam. So my name is Mark. I lead research at OpenAI. And I want to talk a little bit about O3's capabilities. Now, O3 is a really strong model at very hard technical benchmarks. And I want to start with coding benchmarks, if you could bring those up. So on software style benchmarks, we have SweBench Verified, which is a benchmark consisting of real-world software tasks.
All right, so first of all, here's the benchmarks. You can see here's O1 preview, O1, and then O3 at 71.7%. The SweBench benchmark is the best coding benchmark out there. It is real-world coding tasks, and O3 can accomplish it at a 71.7% rate. That is far better than anything else out there, even far better than O1. Then on the right, you can see the competition code benchmark, and here's the ELO score on the y-axis, O1 preview, O1, and all the way up here, O3. Just absolutely outstanding performance.
We're seeing that O3 performs at about 71.7% accuracy, which is over 20% better than our O1 models. Now, this really signifies that we're really climbing the frontier of utility as well. On competition code, we see that O1 achieves an ELO on this contest coding site called Codeforce is about 1891. At our most aggressive high test time compute settings, we're able to achieve almost like a 27 ELO here.
So Mark was a competitive programmer, actually still coaches competitive programming. Very, very good. What is your?
I think my best at a comparable site was about 2,500.
That's tough.
Well,
okay, so let's just break down what just happened. And I'm going to reference AGI one more time. First, what is the definition of AGI according to at least Sam Altman and OpenAI? AGI is AI that outperforms humans at most economically viable work. Now, this person, Mark, the head of research at OpenAI, also a competition coder, was beaten by O3 in the competition code benchmark. Now, if that is not AGI, at least on this dimension, I don't know what is. So think about this. In chess, the best person in the world, Magnus Carlsen, has a ranking, an ELO of 2831. The best AI chess engine is 3700 and above. So it shows AI has now exceeded some of our best minds in these different fields, chess and coding. Okay, so that is proof point number one that AGI has been achieved. And I want to mention one other thing. OpenAI can't technically say AGI has been achieved, or they can, but here's the problem. As soon as they define one of their systems as AGI, Microsoft no longer gets access to it, and that is in their charter. So let's keep watching.
I will say, our chief scientist, this is also better than our chief scientist Jakob's score.
I think there's one guy at OpenAI who's still like a 3,000 something.
Yeah,
Gets a few more months to enjoy.
Hopefully we have a couple of months to enjoy there. Great.
This model is incredible at programming.
Yeah, and not just programming, but also mathematics. So we see that on competition math benchmarks, just like competitive programming, we achieve very, very strong scores.
Okay, let's pause again. Competition math benchmark, 96.7, almost a flawless score. This is a math machine. Then on the right, we have PhD level science questions, nearly 10 points higher than O1 Preview and O1. These are massive gains for this new frontier model O3.
So O3 gets about 96.7% accuracy versus an O1 performance of 83.3% on the AMI.
What's your best AMI score?
I did get a perfect score once.
All right.
So I'm safe. But yeah.
Okay, that's super impressive. He got a perfect score. Wow. All right, so nearly beating Mark, the head of research at OpenAI.
Really what this signifies is that O3 often just misses one question whenever we test it on this very hard feeder exam for the USA Mathematical Olympiad. There's another very tough benchmark, which is called GPQA Diamond. And this measures the model's performance on PhD level science questions. Here we get another state-of-the-art number, 87.7%, which is about 10% better than our O1 performance, which was at 78%.
So I'm going to talk about why this is so important, these benchmarks in particular, especially the PhD level science benchmark. Now, one of the requirements for starting the intelligence explosion, as per the situational awareness paper, is having AI that can do self-research and self-improvement. And so if you have a model that is at the frontier of math, the frontier of science, and is able to actually discover new science, discover new math, and then apply those new discoveries to itself, that is the literal definition of what is required to hit the intelligence explosion. And that's what we're seeing right here, automated AI research. So you take an O3 model, clone it 1,000,000 times, and just let it run and let it self-improve indefinitely. Crazy to think about.
Just to put this in perspective, if you take an expert PhD, they typically get about 70% in kind of their field of strength here. So one thing that you might notice, from some of these benchmarks is that we're reaching saturation for a lot of them, or nearing saturation. So the last year has really highlighted the need for really harder benchmarks to accurately assess where our frontier models lie.
Where do you think he's going with this? I already hinted at it at the beginning of the video, but he's right. These benchmarks are becoming saturated. They're basically beaten or close to it. And so that's why it's important to have a very hard benchmark, something that truly tests if it's AGI or not. Let's keep watching.
And I think a couple have emerged as fairly promising over the last months. One in particular I want to call out is Epic AI's Frontier Math benchmark. Now, you can see the scores look a lot lower than they did for the previous benchmarks we showed. And this is because this is considered today the toughest mathematical benchmark out there. This is a data set that consists of novel, unpublished, and also very hard to
These are extremely hard.
Yeah, very, very hard problems. Even Turnstile says, it would take professional mathematicians hours or even days to solve one of these problems. And today, all offerings out there have less than 2% accuracy on this benchmark. And we're seeing with O3, in aggressive test time settings, we're able to get over 25%.
That's a 10x improvement on this benchmark as compared to everything else that's come before it. This is wild.
In addition to Epic AI's Frontier Math benchmark, we have one more surprise for you guys. So I want to talk about the ARC benchmark at this point, but I would love to invite one of our friends, Greg, who is the president of the ARC Foundation, on to talk about this benchmark.
Wonderful. Sam and Mark, thank you very much for having us today.
Of course.
Awesome. Greg Cameron. So very cool to see him on here. I've talked to him a bunch. He's such a cool, nice guy. And yeah, he's running the ARC benchmark. So really cool to see him on here. Let's see what they do with the ARC benchmark.
Hello, everybody. My name is Greg Camrad, and I'm the president of the ArcPrize Foundation. Now, ArcPrize is a nonprofit with the mission of being a North Star towards AGI through and during benchmarks. So our first benchmark, ArcAGI, was developed in 2019 by Francois Chollet in his paper on the measure of intelligence. However, it has been unbeaten for 5 years. Now, in AI world, it feels like centuries is where it is. So the system that beats ArcAGI is going to be an important milestone towards general intelligence. But I'm excited to say today that we have a new state-of-the-art score to announce. Before I get into that, though, I want to talk about what ArcAGI is. So I would love to show you an example here. ArcAGI is all about having input examples and output examples.
Well, they're good.
They're good? Okay. Input examples and output examples. Now, the goal is you want to understand the rule of the transformation and guess it on the output. So, Sam, what do you think is happening in here?
Probably putting a dark blue square in the empty space.
See, yes, that is exactly it. Now, that is really, it's easy for humans to intuitively guess what that is. It's actually surprisingly hard for AI to understand what's going on. So I want to show one more hard example here. Now, Mark, I'm going to put you on the spot. What do you think is going on in this task?
Okay, so you take each of these yellow squares, you count the number of colored kind of squares there, and you create a border of that width.
That is exactly it, and that's much quicker than most people, so congratulations on that. What's interesting, though, is AI has not been able to get this problem thus far, and even though that we verified that a panel of humans could actually do it. Now, the unique part about ArcAGI.
So I'm going to pause for a second just to reiterate what Greg already said. The reason why the ARC benchmark, the ARC prize is so cool and so important is because it is so easy for most humans to do, to accomplish, to solve, and simultaneously very, very difficult for AI to do. And the reason why this is maybe the best definition of AGI is because it takes learning something, basically taking what you've learned from one example and applying it to another example, both of which have never been seen in the core training set. And that's the important part. So it's able to infer the solution to a new problem based on something it has seen in a previous prompt or previous piece of data. Let's keep watching.
AGI is every task requires distinct skills. And what I mean by that is there won't be another task that you need to fill in the corners with blue squares. But we do that on purpose. And the reason why we do that is because we want to test the model's ability to learn new skills on the fly. We don't just want it to repeat what it's already memorized. That's the whole point here. Now, ArcAGI version 1 took 5 years to go from 0% to 5% with leading frontier models. However, today, I'm very excited to say that O3 has scored a new state-of-the-art score that we have verified. On low compute for O3, it has scored 75.7 on ArcAGI's semi-private holdout set. Now, this is extremely impressive because this is within the compute requirements that we have for our public leaderboard, and this is the new #1 entry on ArcAGI Pub. So congratulations to that.
Thank you so much, yeah.
Now, as a capabilities demonstration, when we ask O3 to think longer and we actually ramp up to high compute, O3 was able to score 85.7% on the same hidden holdout set. This is especially important.
87.5.
Sorry, 87.5, yes. This is especially important because human performance is comparable at 85% threshold. So being above this is a major milestone. And we have never tested a system that has done this or any model that has done this beforehand.
Okay, this is point number 2, why this is AGI. And by the way, if you disagree, leave a comment below. Tell me why, because this is the clearest proof. This is not clickbait. This is true. So if 85% is the human average, and now O3 beats that and essentially beats PhD level science, expert level math, what is left for the definition of AGI? Let's keep watching.
So this is new territory in the ArcAGI world. Congratulations with that.
Congratulations for making such a great benchmark.
Yeah. When I look at these scores, I realize I need to switch my worldview a little bit. I need to fix my AI intuitions about what AI can actually do and what it's capable of, especially in this O3 world. But the work also is not over yet, and these are still the early days of AI. So We need more enduring benchmarks like ArcAGI to help measure and guide progress. And I am excited to accelerate that progress, and I'm excited to partner with OpenAI next year to develop our next frontier benchmark.
Amazing. It's also a benchmark that we've been targeting and been on our mind for a very long time. So we're excited to work with you in the future.
Worth mentioning that we target and we think it's an awesome benchmark.
Yeah.
We didn't go do specific work for this. This is
yes,
just
sure.
The general O3. But yeah.
Yeah, I'm glad they cleared that up. They did not train on the ARC prize. They did not go out and specifically research the ARC prize and how to make O3 work with it. They just made O3 and it just happened to do really well on the ARC prize.
Really appreciate the partnership, and this was a fun one to do.
Absolutely, and even though this has done so well, ARC Prize will continue in 2025, and anybody can find out more at arcprize.org.
Great, thank you.
And by the way, there is a $1 million prize for ARC Prize, and it seems like that might go to OpenAI. I kind of hope it goes to a small team, but it is what it is.
Okay, so next up, we're going to talk about O3 Mini. O3 Mini is a thing that we're really, really excited about, and Hongyu, who trained the model, will come out and join us.
So not only we're getting O3, but we also get the mini version, which is going to be cheaper, faster, and probably nearly as performant.
Hi everyone, I'm Hongyu Ren. I'm an OpenAI researcher working on reasoning. So this September, we released O1 Mini, which is an efficient reasoning model in the O1 family that's really capable of math and coding, probably among the best in the world, given the low cost. So now, together with O3, I'm very happy to tell you more about O3 Mini, which is a brand new model in the O3 family that truly defines a new cost-efficient reasoning frontier.
It's incredible.
Though it's not available to our users today, we are opening access to the model to our safety and security researchers to test the model out. With the release of adaptive thinking time in the API a couple of days ago, for O3 Mini, we'll support 3 different options: low, medium, and high reasoning effort. So the users can freely adjust the thinking time based on their different use cases.
And that's really cool. So if you already know your use case, if you already know this is more of an easier problem or a harder problem, you can adjust the setting accordingly and probably save a lot of money by doing so. Let's keep watching.
So for example, for some, we may want the model to think longer for more complicated problems and think shorter with simpler ones. With that, I'm happy to show the first set of evals of O3 Mini. So on the left-hand side, we show the coding evals. So it's like code versus ELO, which measures how good a programmer is, and the higher is better. So as we can see on the plot, with more thinking time, O3 Mini is able to have increasing ELO, outperforming O1 Mini. And with median thinking time, it's able to measure even better than O1.
Yeah, so it's for an order of magnitude more speed and cost, we can deliver the same code performance on this eval,
or even better experience, right? So although it's the O3 Mini High is still a couple hundred points away from Mark, it's not far. It's better than me, probably.
But just an incredible sort of cost to performance gain over what we've been able to offer with O1, and we think people will really love this.
Yeah, I hope so. So on the right-hand plot, we show the estimated cost versus code versus ELO trade-off. So it's pretty clear that O3 Mini defines a new cost-efficient reasoning frontier on coding. So it's achieved better performance, compared better performance than O1 with a fraction of cost.
Amazing.
With that being said, I would like to do a live demo.
That sounds great.
On O3 Mini.
All right, so we get to see it. Let's see how it goes.
So I'm testing out O3 Mini High first. And the task is that I'm asking the model to use Python to implement a code generator and executor. So if I launch this, run this Python script, it will launch a server locally with a UI that contains a text box. And then we can make coding requests in a text box. It will send the request to call O3 Mini API, and O3 Mini API will solve the task and return a piece of code. And it will then save the code locally on my desktop, and then open a terminal to execute the code automatically. So it's a
very complicated,
pretty complicated task, right? And it outputs a big chunk of code. So if we copy the code and paste it to our server, And then we would like to launch this server.
So we should get a text box when you're launching it.
Yeah.
Okay, great. Oh yeah, I see
I
this
hope so.
Yeah.
It seems to be launching something.
Okay.
Oh, great. We have a UI where we can enter some coding prompts. Let's try out a simple one, like print OpenAI and a random number. Submit. So it's sending the request to O3 mini medium, so it should be pretty fast, right? So on this.
40.
All right, so he used O3 to write code to then hit the O3 model separately. It's so meta, so cool.
Terminal, yeah, 41. That's the magic number, right? So it saves the generated code to this like local script on the desktop and then print out OpenAI 41. Is there any other tasks you guys want to test it out?
I wonder if you could get it to get its own GPQA numbers.
That's a great ask, just as what I expected. We practiced a lot yesterday.
Yeah.
Okay, so now let me copy the code. And send it in the code UI. So in this task, we asked the model to evaluate O3 mini with the low reasoning effort on this hard GPQA dataset. And the model needs to first download the raw file from this URL, and then it needs to basically figure out which part is a question, which part is the answer, or which part is the options, right? And then formulate all the questions, and then ask the model to answer it, and then parse the result, and then to grade it.
That's actually blazingly fast.
Yeah, and it's actually really fast because it's calling the O3 mini with low reasoning effort. Yeah, let's see how it goes.
I guess two tasks are really hard here.
Yeah, the long tail is often the problem.
Go.
Nothing like a live demo.
While we're waiting for this, do you want to show what the request was again?
Oh, it actually returns the results.
Oh,
it's 61.62%, right?
Amazing.
62%, right?
Cool,
With a low reasoning effort model, it's actually pretty fast. Then full evaluation in a minute.
Somehow very cool to just ask a model to evaluate itself like
Yeah,
this.
exactly, right?
And speaking of models evaluating themselves, there's obviously a lot of risk there. We've been talking a lot over the past week about models basically sandbagging and scheming and faking alignment during training time. So we'll see. We'll see what this all means, but it is very cool.
And if we just summarize what we just did, we asked the model to write a script to evaluate itself on this hard GPQA data set from a UI, right, from this code generator and executor created by the model itself in the first place.
Next year, we're going to bring you on, and you're going to have to ask the model to improve itself.
Yeah, let's definitely ask the model to improve it next time.
Maybe not.
Besides code forces and GPQA, the model is also a pretty good math model. So we show on this plot with on this AMI 2024 dataset, O3 mini low achieves comparable performance with O1 mini, and O3 mini medium achieves comparable better performance than O1 if we check the solid bar, which are passive ones. And we can further push the performance with O3 mini high, right? And on the right-hand side plot, when we measure the latency on this anonymized O1 preview traffic, we show that O3 mini low drastically reduced the latency of O1 mini, right? Almost achieving comparable latency with GPT-4o. Where it's under a second, so probably it's instant response. And O3 mini medium is half the latency of O1.
Got it.
And here's another set of evals that I'm even more excited to show you guys is API features, right? We get a lot of requests from our developer communities to support function calling, structured outputs, developer messages.
And these are the benchmarks that are going to be important if you're coding with AI or if you're building agents with AI. Look at that. Tool calling is nearly perfect up here with O3 mini across the board. Very, very impressive.
On O mini series models. And here, O3 mini will support all these features, same as O1. And notably, it achieves comparable better performance than 4o on most of the evals, providing a more cost-effective solution to our developers. And if we actually unveil the true GPQA diamond performance that I ran a couple of days ago, it actually also means that is actually 62%, right? We basically ask the model to evaluate itself.
Yeah.
Right? Next time, we should totally just ask the model to automatically do the evaluation instead of us doing it. Yeah, so with that, that's it for O3 Mini, and I hope our user can have a much better user experience early next year.
Fantastic work.
Yeah, thank you
really
so much.
great work on you.
Thank you.
Cool. So I know you're excited to get this in your own hands, and we're working very hard to post-train this model to do some safety interventions on top of the model, and we're doing a lot of internal safety testing right now. But something new we're doing this time is we're also opening up this model to external safety testing, starting today with O3 Mini, and also eventually with O3. So how do you get early access as a safety researcher or a security researcher? You can go to our website, and you can see a form like this one that you see on the screen. And applications for this form are rolling. They'll close on January 10th. And we really invite you to apply. We're excited to see what kind of things that you can explore with this and what kind of jailbreaks and other things you discover.
Pliny, do your thing. So those are all the announcements about O3 and O3 Mini. It is astounding. It really is. And I'm so excited to test it out. I'm going to dive more into it. I'll put some thoughts together, maybe in another video. If you enjoyed this video, please consider giving a like and subscribe, and I'll see you in the next one.